product of two differentiable functions f and g is itself differentiable. Moreover, the derivative of f times g is the first function times the derivative of the second plus the second function times the derivative of the first. In our formula, if you have a function that's the product of two functions, when you take the derivative, you take the derivative of each function one at a time. So basically what you'll do is take the derivative of the first function, leave the second function as is, plus then you leave the first function as is times the derivative of the second function. Let's look at the example below. Use the product rule to find the derivative of each function. This function is defined as the product of 4x minus 5 times 1 minus 3x. To take our derivative following the product rule, we take the derivative of 4x minus 5, which is 4, times the second, 1 minus 3x, plus, then we do it opposite. 4x minus 5 remains the same, times the derivative of 1 minus 3x, which is negative 3. Distribute the 4 minus 12x. Distribute the negative 3, negative 12x plus 15. Combine like terms, and you have negative 24x plus 19. Our second function is the product of 3e to the x times cosine x. We're going to consider 3e to the x as our first function in the product and cosine x as our second function in the product. We're going to take the derivative of 3e to the x. That stays the same. Remember, e to the x is a special function that has its own derivative, times the second function, cosine x, plus then we're going to copy or take the first function as is times the derivative of cosine x, which is negative sine x. Both terms have 3e to the x, so I'm writing it in factored form, 3e to the x times cosine x minus sine x. Given function f is the product of 4x squared minus 7x times 3x plus 8 with the value of c equal to negative 1. First, let's find the derivative. We take the derivative of our first set of parentheses, 8x minus 7, leave the second function alone, plus first term or first function left the same, times the derivative of the second one, times 3. Foiling these first two, that's 24x squared plus 64x minus 21x minus 56. That's these first four terms. Distributing 3 is 12x squared minus 21x. Those are the last two. Combining all your like terms, you will get a derivative of 36x squared plus 22x minus 56. We're asked to find the derivative when c is negative 1, so basically that's f prime of negative 1. Replace all your x's with negative 1, and your grand total is negative 42. Given the function x times cosine x with a value of c equal to pi over 2. This function is a product of x and cosine x. Our derivative is derivative of x, which is 1 cosine x, plus x times the derivative of cosine, which is negative sine x. Cleaning up your terms, we have cosine x minus x times sine x. In this problem, we were asked to replace c with pi over 2. And so basically that's going to be cosine of pi over 2 minus pi over 2 times sine of pi over 2. And if you remember from your unit circle, cosine of pi over 2 is 0. Sine of pi over 2 is 1. And so we have 0 minus pi over 2 times 1, and that comes out to negative pi over 2. Our trig functions, we have derivative rules for those. Trying to get the screen steady, y'all. We've already looked at the derivative of sine, which is cosine x, and we've also looked at the derivative of cosine x, which is negative sine x. The other 4 trig functions we haven't looked at, you can find these formulas in your Google Drive folder, or if you want to pause, you can write them down. Let's look at our example at the bottom. We have the function defined as e to the x minus tangent x. We don't need to use product rule here because we don't have a product of 2 functions. So it's basically taking the derivative of each term separately. Derivative of e to the x is still e to the x minus, and then the derivative of tangent, that is secant squared. Let's also define a function as negative cosecant x minus cosine x. Now, I shaded these in class so that we could color code and be careful when we were taking derivatives. These negative signs I did not include in the shading. So those lead negatives are the same. The minus sign in the middle, those are the same. Cosecant itself has a derivative of negative cosecant x cotangent x, and our derivative of cosine is negative sine. Be careful to note the highlighted parts versus the non-highlighted parts. These 2 negatives make a positive, so our derivative will be cosecant x cotangent x plus sine x. These last 2 examples, we will do product rule. This top function, we have the product of x to the 4th times sine x. Our derivative will be 4x cubed sine x plus x to the 4th cosine x. Derivative of the first term, derivative of the second term, but leave the others alone. Second function, we have the product of 3e to the x and secant x. Derivative of the first term is 3e to the x. Secant x stays the same, plus 3e to the x. We're going to leave the first term alone. And then the derivative of secant x is secant x tangent x. If you wanted to factor out a 3e to the x secant x, you can. You don't necessarily have to. But this is what it would look like if you did. If we factor out 3e to the x secant x, because that's exactly what that first term is, when we start our parentheses, we only need a 1. And the term in the second half of the problem, if we pull out 3e to the x secant x, the only thing left is tangent x. It is up to you if you factor that out. It's not mandatory.